Hello and welcome. My name is Gurvin and I'm a project manager at the Norwegian Cognitive Center. Today we're gonna learn about some cases from Visma, Visualyst and Rocketfarm. If you have any questions, just ask them in the chat or raise your hand when we are finished with the presentation. Before we start, I'm going to show you some slides about Norwegian Cognitive Center. Behind Norwegian Cognitive Center, there is 5 industry clusters who owns the project. And we have a partner up together with IBM and both research, academia, and public sector and private sector, trying to enhance and start developing solutions using AI. And we are helping different companies for their development of products, operations, or customer experience. And we have 3 main offering, inspire activities like this, where we're trying to show different use cases with companies that has applied AI solutions. And we also have a discover phase where we can help businesses trying to establish use case and develop solutions for them. And also trying to help small and medium-sized business developing AI solutions for those companies who is a lack of competence or need capability to develop solutions. And in our offering, we have a lot of free services that you can use, all from AI competence, the IBM Watson platform, learning arena. We also help organizations with public funding. We have guidelines for how to use AI. We have a lab where you can come and work. And we also have 2 different startup programs. We're also trying to match projects with students and students with projects. And all this is for free. Also mentioned that the next event will be in Norwegian. It's PwC who's gonna talk about how to rig your organization to succeed with AI. First of all, I want to present to you Visma with Sindre Henriksen, who will present a case they have been working with. Sindre, over to you.
Thank you so much. Hello, everyone. Okay, so as you said, my name is Sindre Henriksen. I work in optimization technologies, and we are part of Visma. And today I hope that I can give you some tips on which you can bring along on how to succeed with AI products. So I'd say one of the main reasons we are all here today is that the software landscape is changing. We have had great progress in cloud technology, which enables us to deliver software as a service solutions and to continuously deliver updates and bug fixes and changes. There's been progress in serverless architecture, and this is very important particularly for computationally heavy solutions like AI solutions often are, because you only have to pay for what you actually use and you have unlimited scalability. And there's been a great increase in computing power since the year of 2000. We now have the most powerful supercomputer from then. We basically have in our pockets because the newest processors for mobiles and laptops, they are almost as powerful as the most powerful supercomputer from back then. And all of this has led to increased usability of AI because many of the algorithms have been there for a long time, but they are so computationally heavy that we need all of this processing power. We also need a way to deliver this functionality that we want to create. So that's all well, but how do we actually turn this into something useful and something of value? So what we do in optimization technologies in Visma is that we deliver smartness to the users. And this is something the users are starting to expect. So for instance, if you have a home nursing care software and you dedicate tasks and routes to your nurses visiting the patients, and you know that Google Maps can create routes automatically. You don't have to create your routes any longer privately. You do it in Google Maps. So why shouldn't the home nursing care software do it? And this is a product that we deliver in optimization technologies. And that's only one of several optimization products. And that's in general what we see that users, the one side of the things that users want today, because they spend large amounts of time on tasks like this. And there is a huge amount, there's a huge value of automating this. And even, and if you also can create better solutions, then we increase the value even more. And the other thing that they want is they want predictions. So for instance, they want predictions of how many visits they have to make in 2 months in the home nursing care, or they want more traditional predictions, like predictions on sales numbers, so they can use to guide them in creating orders. And this is not something we have worked a lot with in optimization technologies, but this is also something we are expanding in. So optimization technologies, we are part of Visma, as I mentioned. Visma is a huge software company that you probably all heard about, one of Norway's largest companies and one of Europe's largest software companies, with with more than 18 billion Norwegian kroners in revenue last year, which is about 2 billion euros. And one of the softwares that Visma delivers is the Visma in-school software. This is a resource planning system for high schools in Norway, which is offered to 355 schools. And it is, the system is used by the school admins, by the teachers, by the students, and by the parents. And there are a lot of modules in this in-school software. One of them is a timetabling module. And in this module, they allocate teachers and time slots and rooms to the classes or to the lessons, we call them. And all of these tasks, they require much time and they're very complicated because you have so many dimensions. You have the weeks and you have different teaching groups and you have the rooms and you have teachers and you have a teacher might have a preference, like I don't want to teach on Friday afternoon. Of course, no teachers want that. Then we just have to kind of pick someone, or the timetabler has to pick someone to teach Friday afternoon. And this is something that we try to automate. So the users are supposed to just click this button and let our algorithm run. Then they get the result. And hopefully they will be happy with it. But the issue with that is that if they think of this button as magic, they won't trust it because they don't trust magic. And also it will be very hard to cooperate for users to tell us what they want and what they need to be changed if this is all magic to them, because they don't know the capabilities and they don't know how we work. And the same goes for user experience and UI and backend devs. We have to work together with them. And if they think of this as magic, then that's a huge challenge. So some tips that we have learned along the way for how to approach this issue is that first of all, we want to start with what the users want. We need the users to know that we are not creating some kind of black box optimization AI software that they are supposed to just adapt to. We want to solve an actual problem they have and guide them in their workflow. And of course, most of the guys working in my team, we like very much implementing these algorithms, and we're not UX experts. So we make sure to also involve them from the outset. And we do this so that we can make our solution transparent, that we have an intuitive user interface, but also a transparent user interface. So it has to be clear what the steps are. We have to communicate with the users. Maybe instead of having just one magic button, maybe you split it into multiple parts so that the users can follow along the way and feel like they have more power. The error messages are very important if there are any, or warnings, to make it clear what we mean in terms the users can understand. And the users don't necessarily need to know exactly how the algorithm works, but they want to understand why it makes the choices it does. And for an algorithm like the algorithm we use to schedule lessons into time slots in the schedule, this is actually not too hard. It's just about focusing on that, because that algorithm, it is a local search algorithm. And many of you are probably familiar with that, but fundamentally it works pretty much like a human. It starts from scratch. It tries to put some lessons in the time slots. And if it gets stuck, if it can't fill in all the lessons, then it goes a little back. It takes some out, puts some other in. And it compares different solutions, or partial solutions as we call them, against each other by looking at, did I schedule all the lessons I was supposed to? Did all the teachers get their wishes fulfilled? Of course, someone has to be scheduled Friday afternoon, but maybe a particular teacher doesn't want to be scheduled Wednesday morning, and maybe that's possible to achieve. So it is important to be transparent to the users with this. And optimization algorithms, they are pretty suited for this, because we can explain the choices it makes, and we can also change it manually. Now, if you do have a more traditional machine learning prediction algorithm, this is in the algorithm itself, the neural network, if that's what you use, it will be more of a black box. That is true. But still, the users, they don't want to understand the internal workings of the algorithm. They want to understand kind of the fundamental reasoning behind it. And that is pretty much similar to optimization algorithms, because you just have to explain to users that based on historical data, we found some similar data in the history, and we predicted something similar to that, to the outcome of that data. And maybe if you get a bad prediction, you have to look into, do we have enough data for this? Maybe this was an outlier. Maybe make that clear to the users from the start, that maybe you can give a warning, or maybe you can just tell them that in general, if you have outliers, if you have data that is not too common, it will be very hard to predict. So I guess what I'm trying to say is, don't sell this again as magic. Sell it as what it is, and explain in simple terms to the users what's going on. So we are a pretty young team. We started in 2018, but we do have some solutions out there already that are being used and that are successful. We have kindergarten allocation, which allocates children to kindergartens in Norwegian municipalities. And the municipalities are very happy with this solution, because they used to use maybe about 100 hours, depending on the size of the municipality, of course, in this process. And that would span over several months and involve lots of stakeholders. And now they can click a button and it just takes a few seconds. And they also get better results than they got before. And how do we measure that? Well, it's pretty easy for kindergarten, because they have the children, or the parents have priorities for kindergartens. And if more children get higher priorities, then that is a better solution. We also have a solution for home nursing care, as I mentioned before, where we allocate workers to tasks and determine their driving routes. And this saves time for users both in the planning process, and it saves time for the nurses, because they get more effective routes. So that means they get more time to spend drinking coffee or to spend with the patients. And since you're into this AI, I can mention that the kindergarten allocation, that's a MIP solver. So that's a mixed integer programming solution that solves optimization problems with non-continuous, with discrete numbers. And the route planning solution is similar to the local search in timetabling. And that is also true for the workforce management solution that we deliver, where we assist schedulers in creating schedules for their workers. And this happens within minutes with the optimization product. And that's also an advantage of using AI. It is objective. We don't have the human biases involved here. And it also takes the shift optimizer, it also takes into account the relevant laws and makes sure no laws are broken when scheduling. And finally, of our 4 main products is the timetabling that I have talked about before. So all in all, we are a young team, but we have much experience already. And we have these key learnings, one of them that I tried to bring forward to you today, which leaves us in a very good position for taking on new projects and also for improving on the ones we already have. Any questions?
I think we're going to take the Q&A after, when everybody is finished.
That's fine.
Next one is, thank you very much. Next one is Miguel Silva from Visualyst. You, Miguel.
Yes, hi, Odd. Thanks for that. Let me know if you can see my presentation in full screen.
We see your presentation.
Perfect. Well, thank you, everybody. Good afternoon, good morning, wherever you may be. My name is Miguel Silva. I'm the founder and CEO of Visualyst. We are a company that works with visual analysis software for the film and TV industry, which is just a very fancy way of saying that we work with moderation technology and applied AI, but specific to this industry, specifically for the user cases of the film and the TV industry, because this is an industry that still relies very much on workflows and tools that they were using 50 years ago. They're still using them today. And so we're trying to modernize and make the whole experience of making and packaging TV a lot more dynamic. And specifically, we're working with a problem that's invisible to you and me as viewers of television or viewers of movies. But it's very real for the people that actually license this content and package it for being able to provide it onto a different market. This is a process which is loosely called the compliance review process. And what this basically has to do is whenever you license a catalog from a film studio in the US, for example, from a Disney or an HBO, or if you actually had that content made by a local production house and it's specific to specific to reality TV or specific to a musical production, whatever, or you license movies from Bollywood. Whenever you license something from abroad and you need to publish it onto a local market, you need to make sure that you are not breaching any policies, any regulations, or any laws with regards to audiovisual material. This is because the people that make the content, they pretty much they tell the story that they want to make, and they don't worry about the applicability of that story everywhere in the world. But you as the licensor, when you buy the rights to that movie or to that television program, you do have to worry about the regulations in your local market. Just about every country in the world has a regulator. Regulators have laid out what is okay and not okay to have on TV. For example, in some countries, you're not allowed to show people smoking unless you have a warning about that. You're not allowed to show people consuming drugs. If you're going to have flashing lights, you need to warn the viewer that there's going to be flashing lights. And there's a famous case about that I'll get into it in a bit. There's all sorts of different checks that they do with video before it can actually be published. And that process can actually take a lot of time, and it can be very, very time consuming. These are real figures from a broadcaster that I visited when we were putting together the idea for this product. And just by any means, a small broadcaster which only has 12 channels spends about 2 hours of compliance review work for every 1 hour of video, and that results in a lot of video compliance review time. That results in 156 compliance hours every single day. And like I mentioned, this is work that is done today by small armies of people. There's small teams, or not that small, basically. I haven't met a single broadcaster that doesn't have, or I have actually, but it's typical for a broadcaster to have teams of about 30 people that are working only with compliance reviews. And that varies, of course, by different market, because this is very complex work. What are the regulations of a given market versus another market? But it is very complex, and the consequences of getting this work can actually be very big. There are a lot of fines that get issued. There are broadcasters that get brought down, that get taken off of the air in some cases. The distributors in some markets do get fined. The distributors, who are not necessarily the people that package the content, but are the people that are delivering the video onto the end user. There has been cases, even here in Norway, where they do get fined a lot of money, in the millions of kroner, because they publish things that, according to the regulators, they shouldn't have published. So there's several cases around that. So it's expensive, it's time consuming, it's boring, tedious work that nobody wants to do. And so in our point of view, it's a perfect case for AI to try to automate this, because it's something that needs to be done. But again, it's very, very tedious, very, very manual work. I'll skip, I won't go too deep into the actual cases, but things that everybody understands is a lot of the content now needs to be age classified. You need to be able to say if a movie is adapted for this type of audience, if it's adapted for a younger audience or to a larger audience. There's legal issues involved. There's GDPR issues involved. You need to have permission for, if you have a show that's reality or semi-reality or a documentary, you need to have everybody that you captured on video, you need to have their permission to be able to appear on the program. And that's not always easy to do when you're doing the production. So it's something that's usually handled in post-production. Faces need to get blurred out, et cetera, et cetera. That takes a lot of time to figure out whether you do have somebody's permission or not to appear on video, sometimes. There's technical issues to be involved with distributing a video. And the part that really interests us is, what is broadly called the content compliance or editorial compliance reviews. And these are things like, for example, and they don't not only happen in content that gets distributed for television, but also in associated content like advertisement and video advertisement in particular. There's a specific case, for example, as I use an example here to the right about in the United Kingdom. The Advertisement Standards Agency came up with regulations that specifically prohibit stereotyping a gender in a video ad, an ad that goes on TV. And there's already been campaigns that have been taking off of the air because of that. So you can imagine that this is both very straightforward, very simple work, like in the case of Pokemon, basically, you just need to check whether you have harmful visual composition within your video. But it can also be very, very complex work, like you need to check whether you're breaching gender stereotype rules, which at the end of the day is very tricky, because even as humans, we don't really, we can't agree what is stereotyping a gender between ourselves. So you can imagine trying to make an AI do that is very, very tricky work. And that brings me very much into the complexity of using AI. Before I do that, I just tell you that we have actually cracked a lot of these cases. We do offer a tool that allows the people that work with television broadcasting or distributing video of any kind to be able to bring it into a cloud solution. And then using AI, we pick up all the different events that may be problematic. And then we bring a collaborative workflow on top of that so that a reviewer can say, this is okay, this is not okay. That's a very important part of the process, because as I'm going to go on to mention now, AI, and it certainly was mentioned by Martin as well, quite beautifully, AI is by no means magic. It's certainly not a silver bullet that's going to solve all your problems. It is very, very good, or it's getting better at detection, but it can't make a decision for you as a human. Humans still need to be involved in the cognitive element of whatever the task that you're trying to solve. They still need to be involved, but the AI can help them deal with the volumes. An AI can, for example, go through an entire catalog, many thousands of hours of video, and come up with very concrete results. And it can do that very, very quickly. so that you don't have to sit down and actually watch those thousands hours of video yourself. But it can't tell you whether a specific scene is being sexist or racist, for example. Plenty of people are working on that, but it's not yet at that stage. So to talk a little bit about the challenges, challenge number one is accuracy. Anybody that works with AI will be able to tell you about false positives, which is whenever AI finds something that is really not what it's not meant to be, what it detects, and it flags it as a problem when in fact it's not really what it is at all. And this is a case from our tool, for example, in this particular video. Maybe some of you have seen this movie called Splice. It's a movie that came out in 2009. We use it to test our AI just because it's a very gory type of movie. It's a movie where scientists are blending human DNA with animal DNA to come up with new species. And you get a lot of gory scenes. And in this particular case, you can see that it was detected as explicit nudity. But it's not nudity. It's just that, of course, the material that was used to train it, it sort of looks like nudity, but it's not at all. So that's a very good case of a false positive. And this is why you can't let AI just make a decision whether a movie is adapt or not adapt. But it can tell you like, okay, here I picked 5 instances of nudity. And you can, we also have magic buttons as well, as Martin explained. We have a button where you can click on, this is compliant, this is non-compliant, or this I just want to delete because it was a false positive. That's how we deal with the false positives. However, when as it was explained to me by one studio in Hollywood that I was talking to not that long ago, what they say is that the false positives really we're not that scared about false positives. We can deal with false positives all day long. We're more scared about the false negatives. It's okay to like delete 100,000 clips of things that look like nudity. It's not okay to get a $100,000 fine because you missed nipple, for example. The US is quite Puritan, and the television broadcasting in the US is quite Puritan, and they have a lot of these rules that you can't show, for example, bare nipples on screen, et cetera, et cetera. So that is one. Accuracy is definitely a challenge when working with AI in this space. Challenge number two is one of consistency. Some of you might remember this movie called Basic Instinct. In Basic Instinct, there is one specific scene with the leg crossing scene, which I had to, of course, change. I had to go frame by frame and actually just stop the video right before you get that very famous scene, because in that famous scene, depending on which version of the movie you're seeing, you do actually get to see Sharon Stone's genitals, or you actually don't. If any of you know about how this particular scene was done, they're using a prosthetic and all that. But anyway, in the scene, you do get to see, or like they do have a shot where you see Sharon Stone's genitals. And in this particular case, as you can see, we're picking cases of relevance cases for suggestive clothing, revealing clothing, et cetera, but we're not actually picking the nudity in it, even though this particular policy, our tool works on policies. You define what is it that you want to discover within the video. This particular policy does have a model for explicit nudity detection, and it didn't pick it up, whereas it does pick it up very, very concretely in other cases. Where you do have, in this particular movie has a lot of sex scenes, if any of you remember Basic Instinct. So it's inconsistent in the sense that it will detect genitals. Sometimes it will flag it as nudity, and sometimes it won't flag it as nudity. It will flag it as suggestive behavior. Why? Because AI is like having this new baby. It's beautiful. You get thrilled that it can do new things every single day. But you need to explain what the world is like, and you need to explain to it how the world behaves. And until you do that, until you actually train it, sometimes by example, then you're not going to get the results that you're hoping. That it's really a lot like raising a kid in that respect. And that brings me to challenge number 3, which is context. AI will not understand context the way that it is today. And I'll give you a very clear example. One of the cool things that we're doing right now with our technology is we're trying to apply automatic age classification onto a video. So age classification of a video is also something that today takes a very long time. Today you receive a video, and then either Medietilsynet here in Norway does, or somebody needs to classify it. That can take days, it can take weeks, sometimes it can take months if there's a lot of discussion that needs to happen before they can say whether that video is adapted to this to this age group or to that age group. And the reason for it is because, for example, for a video, according to Norwegian standards, Norwegian age classification standards, for a video to be classified as 18 or above, or for mature audiences, it needs to have very violent content or expression that contains a lot of gross, cynical, and or detailed violent acts. So quite clearly, Tarantino movies are 18 and above, but at the same time, you are allowed to use violence if you're going to go to lower age groups. For example, to get a movie classified as a age 6 rating, it can have violent portrayals are permitted if they are clearly humorous and over-the-top slapstick. And they even use the example of Home Alone for what is actually allowed. But under any other context, if you're actually throwing flame on the head of somebody like you're doing here with Joe Pesci, that's actually quite violent behavior that shouldn't be allowed. And AI will pick both of them and will flag them as violence, but it cannot put it into context. It cannot tell you whether this is slapstick behavior or not. That still needs to be done by a human. There is a lot of research getting done on contextual AI, and my CTO is certainly he's a data scientist and he's very much trained into machine learning. He gets very excited about all the work that is being done right now in contextual AI, but it doesn't exist yet. It's not ready for prime time, so it still needs to be done by humans. So that is the challenges that we found in terms of using AI for the film and TV industry. If you have any questions, if you would like to talk to us, by all means, reach out. We're quite happy to discuss. Thank you very much.
Thank you very much, Miguel. The next one is Rocketfarm with Dan Petter. If you do your presentation.
Hello. Can everybody hear me okay?
Yes.
Perfect. Can you see my presentation? Good. Okay, now I see that you guys are really good at keeping your time, so I'm going to do my best to do that as well. Can't promise anything, but I'll try. My name is Dan. I am one of the robotic systems and AI developer for Rocketfarm. Quick introduction about Rocketfarm. We're still a bit of a small company, so not everybody's heard about us. We were founded in 2008, Sogndal, Norway. We've been working with universal robots since 2012 and AI machine vision since 2018. And if we want to define what we do, we are proud to call ourselves experts on software for universal robots. We do machine learning and image recognition. And by then also, since we practice against industry, we are general tech consultants. So we try to use mostly software as a tool to help automate the industry. Just a quick boast of our fantastic offices in Sogndal, down by the Sognefjorden. We thrive here, and we guessed that we needed fantastic offices to keep fantastic persons in work. So yeah, quick boast. Let's dive into the real material, why we're all here. AI. So I want to present to you Rocket AI, which is one of our later software achievements. And I will start with a very bold claim. Can you see it? Then so can we. And what do we mean by that? Well, we've visited a lot of industry clients for who were curious about our robots. And one thing that was significantly equal in almost every production setting was that automation has come quite far, but you often still need an operator or anyone to check, to have a look, see, verify. So maybe a bit opposite to what the other guys were talking about, but we try to do tasks where we can relieve the operator from tedious or specific tasks, so we can say that you don't have to verify this, we can verify this. And this is the difference between Rocket AI and off-the-shelf systems. You know, there's a lot of systems from big companies who can automatically detect personnel in some settings, like was explained about context. Context is important, but also these systems are very expensive. They might not work for your setting or your environment 100% of the time, and they are hard and even more expensive to adjust. So we don't do off the shelf. We build specific models based on your images and your data. And by your data, I mean your expert validation and assessment of the images. What does this image contain? And also we base hardware on your environment, so we can handle most every environment or any setting needed. It's all a discussion about what kind of precision and what kind of speed you are required to have in the system. So I usually say that proof is in the pudding. So I want to talk about how we do projects and show you a few and do that through a few examples that we've actually made. So I will start with this. We made for Hydro, a bigger company that I suspect most of you have heard of. They produce aluminum through an electrolytic process. The electrolytic process needs a lot of current flowing, which suggests you have a positive and negative side of electric power. And these gray, I would say, like caskets, not caskets, but maybe boxes. They're quite big, a couple of meters long. They function as anodes in this system, and they are eaten up through the process. They are quite black. You cannot see that in these images because the lighting is quite good. Hydro had tried a lot of ways to trace these anodes from creation until they're spent. And they struggle with it because the anodes, as part of the producing them, after they are pressed, they go into a furnace where they are baked at 1200 degrees for 3 weeks. So the numbers go in, as you see from the top images, and they often come out as you see on the bottom image, or worse. So we started a proof of concept, and Hydro wanted us to try to register the debossed serial numbers. This is sort of one of the simpler tasks you can do with AI, vision AI. It's called OCR, optical character recognition. And so we did that in the proof of concept, and Hydro, they wanted us to use hardware that could stay. If they were happy with the concept, they wanted the hardware to stay. They didn't want sort of a cheaper in-between solution. So that's what we did, and they were happy with the results. So we started to add several more stations, and also started adding stations after the baking to try to identify the serial numbers as they come out from the furnaces. And so we started, as I said, with a simple proof of concept. Can we register all the debossed serial numbers so that they had good tracking on every single serial number made? And we've ended up with providing them through the implementation projects after the proof of concept with full life cycle traceability of every anode they produce, at least for the aluminum sites that also have our station for tracking the anodes before they go into the actual aluminum production. And this has led to us actually having Hydro as a recurring customer. We are now currently solving new challenges for them with our vision systems. Just to show you a bit what I mean with difference in complexity, this is quite easy. You can see that the letters are slightly blurred. There's no challenge really. And we do fitted boxes around the digits, and we get 6 digits all recognized 100% certainty without the model being overtrained, which is a AI issue that some of you might know about. So this is sort of the easy part, the easy task. You can call this what we had to do for the proof of concept. Now, going further on, this is an example of a serial number coming out from the furnace, which is still quite good, really. To me, who know the fonts, it's quite readable. Some of you might starting to maybe have a second look at that number 6 up there. But what if we come to harder challenges, or even harder than this one? It's starting to get hard to see. And it might not look it, but this is with quite good lighting as well. So this is a task that they couldn't put personnel for. You know, they produce these anodes in the thousands. They cannot put people looking at the anodes at every part of the process. It's simply too expensive. So I would say that we have reached the goals here, and we are producing a lot of data for them on where an anode is at any given time, and how it functioned. So quickly further on, how does an AI work? For you, all of you who know AI on Vision, please bear with me. I've tried to squeeze sort of a simple concept into one page here, but this is an idea of how we solve this particular task. At the bottom left, you can see an anode in white with black numbers on it. We take an image of the part that we know that's interesting. We condition the image. We put some squares on it. And these squares, no, can you see my pointer? So we square up the image, and we put these standardized boxes on them, and we move the boxes over every possible combination of the grid. And so these boxes we call anchors, and the anchors give us a score for looking at silhouettes, or what we call a feature map. Like we could recognize a shadow as looking at something. Maybe you see a shadow from whatever object looking like a person, and your brain will immediately tell you that this is a person. So the same thing happens in AI, is just that the features are quite different from what we are used to look at. Okay, I will not dive deeper into this. Another one, we have Norwegian. They produce crystalline silicon wafers. They put a lot of material into a crucible, which is to be melted, so they can start making what they call an ingot out of crystalline silicon. So operators, they have to check if the crucible has had all the material melted, so they can add more, because when you add the material, you squeeze air out, and so you have to add more material before the crucible is full. So, okay, that's easy if you have one, and it doesn't take much time, but Norwegian has 70 of these. And the operators are walking, running, biking between them to have a look and decide if it's time to add more material. In this project, for the proof of concept, it was a really high focus for the customer not to spend a lot on hardware that will not be reused later. So they wanted us to use cheap hardware. What we did was that we coupled up one-board computers to the existing cameras, which were old 640 by 480 black and white cameras. Most of the image pixels were burned out from the strong light of the crucible. And still, we were able to beat the operators by 5 minutes in average. So with the amount of electric power going through these furnaces, then that actually accounts for millions in saving every year. We are still hoping for this project to go on to a full-scale implementation project. But this is usually the way we work. We do a proof of concept, try to do it, within a reasonable budget to prove that we can do this, so that there is a lot more certainty when going into a full-scale implementation. Last example, we have Boliden in Odda. They produce zinc through also through electrolytic process. And what you can see in the image here is what's called a cell top. So the person here is walking on this cell top. Each of these strips that you see are actually very long metal blades, which are dipped into an acidic pool. And the image is taken from a camera latched to the crane, which picks up a bulk of these blades and carry them at low height over the cell top. Boliden wanted us to detect personnel, because personnel have to walk around on the cell top performing various tasks. They were afraid, what if this crane runs someone over while carrying all these blades? It might be severe. So they wanted us to see if we could detect personnel and stop the crane. Now, you could say that there's a lot of off-the-shelf systems that could do this, but there isn't. Boliden tried all of them, I would say, many of them at least. And because of water vapor and mist hanging over there in a lot of the time of the year, the other kind of systems failed. So we started the proof of concept by latching a GoPro to the crane. And we did like time series pictures. Now have a look at the boxes. The box now is green. It will turn yellow shortly, and now red. So yellow means that it's just a graphical representation that we use for the customer to show how would we treat the data. And yellow means, okay, you're getting too close. Let's activate the emergency stop of the crane so we don't run him or her over. Red is the crane won't have time to stop, but we will try to stop it, and we will give a sound warning that you should move out of the way. The proof of concept model is working, that you can see here, is working at only 2 Hertz. So it's nothing wrong with your feed. It's made like this. The proof of concept was considered a success. The boxes are not perfectly fitted here around each person, because we have done this with very limited amount of data, again, just to prove the concept. And we continued, when Boliden saw these results, we continued into a stage 2. They wanted to do an incremental process. So we bought in the, this is a very acidic environment, by the way. So we bought in hardware which could survive in this environment to harvest more data, make better models, prove that this will actually work in real life. And now we are at the full-scale implementation project, coupling our system up to the crane. We can automatically sound the alarm and stop the crane, working at between 15 and 20 Hertz. So it's quite responsive. So any more questions about this, I'm happy to answer them. I tried to do like a brief understanding on how we approach the different tasks or challenges that customers might have. Thank you.
Thank you very much, everybody. If Don and Sindre and Miguel, please could ask some question from the audience. Now just unmute and ask the question. I'll start. What of those different solutions you are presenting, what's the most time consuming in developing the different AIs?
I could start if you want.
Yeah.
In many industrial cases, which are our cases, it's it's what takes the most time, not having to work with it continuously, but stretches over the calendar, is gathering data, getting good data. Because if you work with more complex and rare cases, the rarer it happens, the less data you're going to get each day. So that is one of the most challenging things. And the second one I would say is to actually gather the field of expertise from the operators who work there today, and be a medium to transfer that knowledge over to the data. Is also quite time consuming. Some of it can be automated, but in many cases, it's a lot of manual work.
Miguel, you have a lot of data. What's most time consuming for your part?
Yeah, you can never have too much data is certainly what we're figuring out. For example, one of the some other things that we're looking at is automating the entire process of reporting onto different brands, the instances in which their brand has been used as a product placement in an episode. Because today that's also something that people do manually in this industry as well. You have somebody sitting down watching TV, say, "Oh, there's a Coca-Cola bottle. Oh, there's a Coca-Cola bottle," and then they send a report that says, "Today you had 5 placements of Coca-Cola, to Coca-Cola." No? But then you can create the training set, or you can receive a training set of 100 or 1,000 different variants of the Coca-Cola logo, so that you can train your model. But then you also need to get it into different angles, different positions, different color schemes, monochrome, et cetera, so that you can have the most accurate detection possible. And just creating that data set is the most time-consuming part. And once you start, you usually realize that you miss something, and so you need to keep on feeding it all the time. It's like I said, it's like raising a baby.
Yeah. And Sindre, for that route planner, are you gathering real-time data also to guide the car for the home services?
No, not as of now, but that's definitely something we are looking into. But so we get only kind of one-time data input for the optimization algorithms that we have. We try to deliver these services as we prefer to deliver them as APIs. And most of our time goes to setting up kind of the infrastructure and where to host the solutions, how to deliver them. And also, of course, meeting users and UX developers and discussing how we want this to look and behave.
If you should inspire other people to start looking into how to use AI in their field, where should they start?
It's a very good, tough question.
Yeah.
Anyone else has any immediate ideas?
You're asking everybody?
Yeah.
Yeah, okay. No, where to start with AI? I fully agree with what you said, Martin. Is you need to start with, like, what is the problem that you're trying to solve? Forget about the AI. Forget about the technology. What is it that's so time consuming that it's worthwhile to try to automate? Because not every problem is like suitable for AI. Not every problem is worthwhile automating, no, as we all know. And then once you do find something that, this is an unnecessarily large amount of hours, then you can start seeing what are the complexities of AI, what are the challenges of AI, and you can start working around those. Yeah,
definitely. We had a guest presentation in Visma from, I think it was from someone in Google, who had this great quote. He said, if you don't have a question, I don't have an answer. So you can't just say, give us some AI. You actually need a problem that you want to solve.
Also, if you have a good place to start is if you have challenges that you've been trying to solve for a while, and at least for our systems, if you need someone to go have a look at something like frequently, that used to be very hard to automate. Now it's getting a lot easier. So, for example, this hydro task, they've tried to automate since the 80s. So if you have something that you cannot put someone to do, or you have to put someone to do it, but no one wants to do it. If it's good HSE or expensive to do today, then you can evaluate. Okay, maybe we should try to see if there's new solutions to it. Then AI might be the answer, and then the next task would be to contact someone who could answer that for you. Is this a good task? Is it, or is it not? People with, it's hard for us with domain knowledge about AI to envision absolutely every possible usage. But if someone has a specific task, it's easier for us to evaluate it and say, yeah, we could probably do it, or no, you should try to find something else.
And that also goes both ways, that the domain experts don't have AI expertise. So also it's important to be proactive, be out there and discuss with people, and maybe together you can find something.